Good day, students. Welcome to another edition of Patricia e-learning. Today, we'll focus on the topic gears. Gears are made up of two wheels of different sizes or diameters. These gears have teeth of equal size cut along the surrounding of the circumference. It is designed so that the teeth of one will fit into the groove space or spaces of the other accurately. In this way, the teeth of one cannot slip or skip from the other. These gears are what made machines to function either for work or for movement. A gear is a device used to transmit power or energy from one part of a machine to another. It can also be defined as a rotating part having teeth which meshes with one another and transmit motion between rotating shafts. Types of gears are 1. Helical gears. This is a cylindrical shaped gear with helicoid teeth. It is used to transmit motion between parallel and non-parallel shafts. We have the spur gear, which is the most common type of gear. They have straight teeth which are parallel to the axis of the wheel. Spur gear is used to transmit motion between two parallel shafts. We have the bevel gear, which is used to change direction in drive in a gear system by 90 degrees. We also have the worm gear, which is used to drive the spur or helical gear. They are normally used when a high gear ratio is desired or when the shafts are perpendicular to each other. The rack and pinion says in this type, a slowly spinning gear which is called the pinion meshes with a flat ridge bar which is called a rack. It is used in automobiles to convert rotary motion of the pinion to linear motion. We have the internal gears where the teeth are formed on the inner surface of a cylinder or cone. We have the external gears. The two gears meshes externally. The larger one is called a spur and the smaller one is called a pinion. Let's see the uses of gears. 1. Gears are used to transmit power from one shaft to another and thereby causes motion. 2. Gears are used to select and change speed of motion. And 3. Gears are used to change the direction of motion. Let's see its advantages. 1. It can transmit larger power. 2. Have high efficiency. 3. It provides positive drive without slip. 4. Suitable for high speed. And number 5. Use very little space. Let's see its disadvantages. 1. It could become noisy when not lubricated. 2. Would damage quickly if misaligned. And 3. Costly to produce and maintain. While its applications says gears are used in mechanical devices that requires transmission of power from one point to another, rotation or speed and direction of motion. These are the ways gears can be applied. Now let's see what is gear ratio and speed rotation. When two gears of different teeth mesh each other, one is known as the driving gear. We transfer the effort to the other gear known as the driving gear. The ratio of the teeth in the driving gear to the driven gear that is meshed together is called gear ratio. The ratio is mathematically expressed as ratio equal to NA all over NB, where NA is the number of teeth in gear A and NB is the number of teeth on gear B. Let's see example 1. If the driving gear NA has 40 teeth and the driven gear NB has 5 teeth, what is the gear ratio? Now in substituting the ratio here, we have NA all over NB equals to driving all over driven. So R, which is our ratio here, says 40 all over 5 or 40 divided by 5 equals to 8 all over 1. So our ratio is what? 8 ratio 1. Let's see speed rotation or speed ratio. This is the number of times the driven wheel gear, which is NB, will turn against the driving wheel gear NA. It clearly states that the speed depends on the gear ratio. The wheel will run faster when the number of teeth in the driving gear is greater than the number of teeth in the driven gear. Also, when the number of teeth in the driving gear is less than the number of teeth in the driven gear, the driving wheel will turn slowly. This is clear that the speed of two wheels of a gear is inversely proportional to the number of teeth in the wheel. That is, speed of gear A all over speed of gear B equal to the number of teeth in gear B all over number of teeth in gear A. Now let's see an example here. If gear A, which has 60 teeth, is meshed with gear B having 20 teeth and rotate 40 times, how many times will gear B rotate? Now the solution here says number of teeth in gear A all over number of teeth in gear B is equal to speed of gear A all over speed of gear B. Now number of teeth in gear A is 60 and number of teeth in gear B is 20. So we have 60 over 20 equals to B all over 40, where B is the speed of gear B. So let's have a cross multiplication here. We have B times 20 equals to 60 times 40. So we have B times 20. When you multiply, I have 20B equals to 60 times 40, which is 2,400. So B, making B the subject formula, I have B all over B is equals to 2,400 divided by 20. So B is equals to 120. Therefore, gear B will rotate 120 times. Let's see example 2. If a 40-tooth gear rotating at the speed of 20 rpm drives a 20-tooth gear, what is the speed of rotation of the 20-tooth? Now our solution here says rpm stands for revolution per minute. Let the speed of the driven gear be what? X. So I have 40 teeth times 20 rpm. Here rpm stands for revolution per minute. Is equals to 20 teeth times x rpm, because the other one is unknown. So making s rpm the subject of formula, we have s rpm equals to 40 teeth times 20 rpm all over 20 teeth. So s rpm will be giving us 800 all over 20. So our answer is there is what? 40 rpm. So the driving gear rotates at 40 revolutions per minute. Now let's see what lubricants has to do in gears. Lubrication is the process of applying lubricants such as oil and grease to moving parts in order to reduce wear and tear caused by friction. While lubricants are substances such as oil and grease that is applied to two moving surfaces in order to reduce wear and tear. It's important to lubricate all moving parts of a machine so as to achieve the following: 1. Overcome friction. 2. Prevent excessive wear between moving parts. 3. Act as a cooling agent to reduce friction. And number 4. Protect surface from rust. 5. Fill the space between metal parts, thereby acting as a cushion. How to make a simple gear using a cardboard paper. A cardboard paper can be used to demonstrate a very simple gear. The materials needed are as follows. 1. We have a hard cardboard. 2. We have the compass. 3. We have the pencil. Number 4. We have the ruler. And number 5. We have the pair of scissors or razor. Now the steps to follow is 1. Using the pair of compass and pencil at a point, draw out two large circles on the cardboard, the bigger one representing the top and the smaller circle the root of the gear teeth on the cardboard. And number 2 says divide the circle into number of equal parts. 3. Carefully measure out equal distance to represent the width of the gear teeth in the space between the big and small circle. 4. Use a pair of scissors or razor to cut out the teeth. Now assignment here says if gear A with 80 teeth is meshed with gear B having 50 teeth and rotates 50 times, how many times will gear B rotate on its own? Number 2 says explain the importance of lubricants in gears and other moving parts of a machine. Do have a wonderful day and God bless you.